got number 12 says, what is Dalton's atomic theory and which parts of it is or are incorrect? Okay, so the first thing he said was that atoms were small and indivisible masses, and we know that that's not true. They are small, but we can split the nucleus. So that's false because of him saying it was indivisible. And then he said that all atoms of the same element were identical. But we know that there are isotopes, so that won't be true. Now they do all have the same number of protons, but their neutrons can differ. Because of isotopes, we know that that's a false statement. And then he said that atoms can combine to form compounds. And we like that one. So we're going to go with true there. And then he said that atoms can be let me erase that. Let's say that a little bit better than that right there. Let's say that during chemical reactions, there will be a rearrangement. Of atoms. There will also mean they can be joined or separated during a chemical reaction. Okay. Now, number 13 says, by what experiment did Rutherford discover the nucleus? So let's scroll on down and take care of number 13. And what he did was the gold foil experiment. There's a picture of that in your notes, but basically he shot a beam of alpha particles at thin gold foil screen. And I guess you could call it a screen. And surrounding that he had a fluorescent screen, and he knew that if the alpha particles made it through, they would hit the fluorescent screen and give off some light, but he began to notice that some of the alpha particles bounced back, and that told him that there must be something in the way. And some were deflected at angles. And so he thought, well, the ones that are bouncing back must be hitting something solid. So he thought there must be something in an atom that was solid and densely packed. And that was the nucleus. Okay. All right. Number 14 says describe J.J. Thomson's plum pudding model. And so what I said was in this model, the plum pudding model, the electrons are stuck into a lump of positively charged material. The electrons are stuck in a positively charged material. That would be the pudding. and the electrons would be representing the plum. How many protons and electrons are in a neutral atom of sulfur? So I go to my periodic table. Sulfur has a symbol of S. When I look at my periodic table, I know it's element 16. And since it's neutral, that means I need 16 protons and 16 electrons. Because remember, 8-man, APE, atomic number equals protons equals electrons. What does the atomic number of an element represent? It represents the identity of the element. Because it tells us how many protons are located in that element. Gives us number of protons. What is the mass number? The mass number, that's your man from 8-man. Mass number minus atomic number gives you neutrons, so the mass number is equal to the number of neutrons plus the number of protons. All right, sulfur 32 and sulfur 34 differ. They're isotopes of sulfur, so they have sulfur 32 has 2 less electrons than sulfur 34. How many protons, electrons, and neutrons are there in a neutral element of carbon 13? So 13 is the mass number. So 13 minus atomic number 6 gives me 7 neutrons. 6 is the atomic number. And 8-man tells me that the atomic number equals the number of protons. It also equals the number of electrons. Okay, I'm going to pause for a second. All right. Okay, now we want to know how many protons, electrons, and neutrons are there in calcium 2+. So that's an ion, so it's missing. The reason it's 2+ is it's missing 2 electrons. So if I look at calcium on the periodic table, it is number 20. So it has 20 protons. It's missing 2 electrons, so it has 18 electrons. And then I have to look at the mass of calcium, and the mass of calcium is 40. So 40 minus my 20 protons tells me that I have 20 neutrons. All right, then I have a question. What is the name given to the following groups of elements? What are their physical characteristics? Which ones are representatives? All your group A elements are your representative elements. So anything that has an A in its group number is a representative element. And they have a wide range of characteristics. So that means that some are going to be metals, some are non-metals, some are metalloids. So as we go over the properties of those things, I think you'll see what's going on. Okay, group 1A is called the alkali metals. And the alkali metals, they're shiny, they're soft, they conduct heat and electricity well. Okay, see if there's anything I left out. Oh, they're highly reactive also. And they are highly reactive. All right, so it's getting a little messy, so I'm going to get rid of that and then just keep on working on the next one. So we've done part A and part B. Now we want to go to the group 2A. Those are called the alkaline earth metals. Oops. They are also conductors of heat and electricity. They're not quite as soft, so they're a little bit harder. They shiny. They're shiny. They are reactive. They are solid at room temperature. All right. The 7A. 7A is called the halogens. They're nonmetals. So that means they do not conduct heat and electricity well. Astatine and iodine are solids at room temperature. Now at room temperature, the bromine is a liquid. It has to be at room temp. And then at room temperature, my gases are chlorine and fluorine. Now, fluorine is very reactive, so she's often called fluorine the floozy. Chlorine, C-H-L-O-R-I-N-E, is a little bit less reactive, and they're dangerous, so we have to be very careful with those gases. All right, I'm going to stop there, and I'll do the next part